Today's objectives is simplify expressions using rules of exponents. All the rules from before, and then we're going to apply them to different kind of situation within a problem. So there's different steps in it, and you guys can pause it and then just copy it for now. This is the list of the rules that we are going to be using. 0 as an exponent, a to the 0 power is 1. Negative exponent, if you have a negative exponent, you flip top and bottom. The product rules for exponent is the base is the same, you add the exponents. Quotient rule for exponents is pretty much the 1-to-1 cancellation. Who has a bigger exponent, that's where you put the number. Then the next one is raising to a power. I ask you guys to think about it. How many do you have? So it's just multiplying the exponents. Raising product to a power. Whatever is the base is going to get the exponent for all of them. Then raising a quotient to a power. It's the same thing. Now we're going to look at example number 9, following the rules that we have. If you think about it, there's a couple things you can do. There's different ways of doing this problem. As long as you get the right answer and you show me the correct work based on what you give me. If you don't give me the correct work when I check, you are not going to get the credit. First thing I would do, because I really don't like negative exponent, I would just flip to the bottom. So the rule goes like this. You can have 1 over, because if you flip to the bottom, that's n to the second, n to the fifth. And then the 3 still have not changed. Then n to the second, n to the fifth can be combined. That's n to the seventh, n to the third power. We do one little step at a time. Because they are in the same rule side by side, you count how many is there. Now in your head, you can think about it. That's 1 over n to the 7, 3 times. So it's n to the 7, n to the 7, n to the 7. So how many n do we have? Well, that's 21, or you can write it out, 7 plus 7 plus 7. So this is really just 1 over n to the 21. And quick thing, if you want to think about this, that's like n to the 7th times n to the 7th times n to the 7th. Okay? Or another way I want to show you, I'm going to show you a couple of them with one way. All right, so that's the first way you can do it. Next way you can do it is you can do it by saying, hey, we have n to the negative 5 minus 2 if you want to do it that way. I don't like memorize the formula just because. And that's going to be, because I can forget the formula. That's going to be n to the negative 7 and to the third power. And if you want to flip it, or you can multiply it, because that's a power of a power. So that's n to the negative 21. And that's going to be 1 over n to the 21. That's another way. Or you can have n to the negative 5 minus 2 to the third power. You can have n to the negative 7 to the third power. And then you flipped it. 1 over n to the 7 to the third power. And you have 1 over n to the 21. See, there's quite a few ways of doing it. So either one will be correct. So it's up to you which way you want to show me. But I hope you notice there's absolutely work involved. If you don't show me work, you will not get full credit. Let's move on to example number 10. Example number 10, m to the negative 6 power, or you can flip it, but I think flipping a a fraction top and bottom gets a little bit hard. So I distribute those two. And another way you can think about it is you want to take the top fraction and take care of the bottom fraction because the top fraction has a parenthesis around it. So you want to take care of the parenthesis part first. Parentheses only on the top, not top and bottom. So on the bottom, I'm just going to treat it like another problem. I will just combine them because they are already side by side. If you combine them, that's n to the negative first power. And because of that, you can do m negative 6 minus a negative 1. And that is going to be m negative 6 plus 1. And that's going to be m to the negative 5th. And if you have a m to the negative 5th, that's really equal to 1 over m to the 5th. Or you can do it another way. M to the negative 6 over m to the negative 1. Flip top and bottom because they both have negative. M to the 6, m to the 1st. And then if you want to, you can just say bottom is bigger, has more m to the 5th, and with 1 on top. I don't care which way you do it. But did you guys notice I follow all my rule correctly? There's more way than that. Let's try one more. Notice the top and bottom. The top and bottom have parentheses by themselves, not all the way around. So I'm going to take care of the parentheses part first. So if you take care of the parentheses part, that means the top is going to be 2 of them. If it's 2 of them, that's going to be 16 y to the 6, because y to the 3rd, y to the 3rd is y to the 6. The bottom is going to be 2y to the 4th 5 times. If you do 2y to the 4th 5 times, some of them I'm going to just write it out so you can understand what I'm talking about. 4, 3, 4, 5. So in this case, 2 to the 5th power, y to the 20th power. So y to the 20th power, I'm going to put down right here. And then 2 to the 5th power. Now 2 to the 5th power is really 32. Y to the 20th, that's going to be 1 over 2. When you reduce the y to the subtraction or to the one-to-one coverage, that's going to be the 14. This is my thought process. Number 12. Now, what's the difference between number 11 and number 12? Notice number 11, the parenthesis is on top and bottom. Number 12 is the parenthesis of the whole thing. So if the parenthesis on the whole thing, I can take care of stuff that's inside the parenthesis first and then distribute. Or I can use the top, I can use whatever's on the outside. But usually I like to simplify inside the parenthesis first before I work outside. The reason for that is because the inside the parenthesis will make it smaller. That makes it easier to deal with. In this case, I'm going to do is I'm going to say, I'm going to flip x to the 2nd. And then since it's a negative exponent right here, I'm going to move it to the top. That's going to be times x to the 5th. Because it's bottom, move to the top. Then I'm going to have negative 4. Combine inside first. That will be x to the 7th power to the negative 4. It's going to be x to the negative 28. And then it's going to be 1 over x to the 28th power. And another way to do this, you can also do distribute x to the negative 8 over x to the 20. But I don't like this way too much because the number gets bigger. And so you do x negative 8 minus 20. That's equal to x to the negative 28, and that's going to be 1 over x to the 28th power. So notice there's so many different ways of doing this. Now number 13 have a division sign right here. Division sign means that you put that in the bottom. So let's rewrite it first. So that's going to be y to the negative 2 times y to the negative 3 in parentheses negative 4 over y to the negative 15. Now notice the parenthesis is only just on the top, so I want to handle that part first. So that's going to be y, since they are side by side, is adding the exponent. So it's negative 2 plus a negative 3. So that's going to be y to the negative 5th power to the negative 4th power over y to the negative 15. Y to the 20th over y to the negative 15. Now, if you want to just subtract, which is fine, don't forget that's y to the 20 minus a negative 15. And that's y to the 35th power. Because negative is positive. That's one way you can do it. Or another way you can do it from here, you can say, I'm going to do y to the 20th. And then I'm going to flip the y to the negative 15 to the top times y to the 15. And that's equal to y to the 35th. Example number 14, the parentheses top and bottom. Make sure you do the problems like the top is a small little problem, the bottom is small little problem. You should not combine them because they don't square the same way. So absolutely no combining top and bottom until you take care of everything on top, on the bottom separately. So let's take a look. So you have the top. If you distribute them, you're going to have negative sign, all kind of stuff. It's getting really confusing, but that's the one way we can do it, because if we flip it to the bottom, you can totally do that too. Because 2x to the 4th to the negative 3, that negative 3 tells you everything on the base can get flipped. So that's going to give you 2x to the 4th, the whole thing to the 3rd power. Then this negative sign right here tells you to go top. Top is going to be x to the 2nd power, y to the 3rd to the 2nd. Now notice there's no more negative symbol. I just don't like negatives. So if I don't have to deal with it, I try not to. Now take it out of the parenthesis for top. That means you are writing that x squared y to the 3rd twice. If you write it twice, then that's going to be x to the 4th, y to the 6th. On the bottom, that base is 2x to the 4th, so that whole thing has 3 times. So that's 2 to the 3rd power, x to the 12th power, because 2x 4th 3 times is x 4th, x 4th, x 4th. So 3/4 is going to be 12. So now you can actually combine them. So you can have x to the 4th, y to the 6th. On the bottom is 2 to the 2 times 2 times 2, 3 times, that's 8. And you have x to the 12th. If there's, as in top and bottom, you have that 1-to-1 coverage, and that gets canceled. So 8 on the bottom stays like that because there's no other number. But x to the 4th and x to the 12th, you can cancel x to the 4th with x to the 4th on the bottom. So that gives you x to the 8th. And the y doesn't have anything to cancel, so y to the 6th. Thank you very much for watching.